Hey guys, so this little video here is to kind of show you guys what's involved in catching the International Space Station passing in front of the moon or the sun, and just what's involved in the whole process, making sure that your event is successful. So what we're going to do is we're going to jump into the laptop here first. We've got a transit tomorrow morning at 11:14 that's fairly close to the house here. Yeah, I guess close is relative. So what you want to start with is this website here, transit-finder.com, transitfinder.com. It is, in my opinion, probably the best website for the layperson if you're just an amateur like myself. CalSky does a fantastic job too, but there's a lot of technical information there that I don't understand nor need to know in order to capture one of these. So I like transitfinder.com here. First thing you want to do when you go to the website is you want to, if you're on your phone, auto detect and it'll pick up your GPS location, or select your location on a map. Now I've got my location picked here, and what that does is that kind of gives it a starting point, which is important for the next step here. So you want to pick the time frame that you're looking for. It'll only let you go 1 month out. So this is tomorrow's date. I'm recording this on Thursday the 11th. And then you want to pick your range, and I believe this will go up to 500 kilometers. Don't quote me on that though, I've never tried. I leave it at the default, 150 kilometers, because that's about as far as I want to travel for a lunar or a solar transit. And after that, you just hit the calculate button. So we calculate, and it'll bring up a list of all of the lunar and the solar transits that are going to take place in that time frame that you put in the calendar there. So you can see that it's found 5 upcoming lunar transits and 8 solar transits. Now, for me, the most important bit of information here, besides the location, which we'll see on the map here in a second, is in the ISS angular size. So what this does, you want this number to be 50 or above. So this is a really good pass that's happening tomorrow morning. 11:14:41 is the time. Make note of that time there, 11:14:41, because you're going to see that that changes by a few seconds here in a second. And also the angular size is going to change too. This is, to me, the most important number on the whole page here. It tells you just physically how big the ISS is going to be as it transits across the sun. There's a little bit more information in here that really tells you a lot of information that some of you may want to know, some of you don't. I don't find much of this information really that useful for me. I'm not tracking the exact angle that it crosses the sun or anything like that, because my imaging train is a Lunt 80 millimeter solar hydrogen alpha scope, and the camera is a ZWO 1600 monochrome version, the cooled version, because I use it for my deep sky imaging as well. And with that combination, I get a full frame image of the sun. Now I could crop in and get a smaller portion, but it's not going to be any bigger. So with this, I am able to get a full frame image of the sun. So the angular, the direction of travel, and exactly where on the sun is not going to matter, and you'll see why here in a second. So what I do is I go to show on map, and you can see that I'm just right on the edge of my 150 kilometer radius here. But the reason I'm going after this one is because of the size. Like I said, anything above 50 arc seconds, and it's worth traveling for. So I'm going to zoom in on the path here and get a little bit closer, and you'll see that it passes right over Highway 95 here. So my initial plan was to go to this location here. The red path, you have to be inside this red path here in order to actually see the transit. So you can see that it's a fairly narrow path. So my plan was to go up past Armagosa Valley here, take a left on this road here, and come down and park myself right here on the side of the road. By doing that, you can see the angular size is now 55 instead of 64. So it's a little bit different size, but it's still above 50. So in my book, this is a good transit. You can also see that if I park right here, it transits directly across the center of the sun. If I zoom out a little bit here and get a little more out to the edge of one of these, of the red path, you can see that it's just barely going to clip the edge of the sun. So that's why it's important. You want to be as close to that center line as possible. So I'll close this. And this was my initial choice here. It was right here. Note the time. Now it's 11:14:34. Forget the tenths and hundredths of a second there. 11:14:34 is the time at this location that the transit will take place. And you can see the duration of the transit is only 0.62 seconds. So it's, that's typical. I mean, this sucker is moving, so it doesn't last long. You blink, you miss it. But one of my concerns with this transit tomorrow is the weather. It's going to be really windy tomorrow. And this area of the desert is very flat, wide open. I'm not going to have any protection from the wind. So I decided to go to another location, a location I happen to know, even though it's outside of my 150 kilometer radius here. I'm going with a friend of mine, and we are going to probably have lunch at Furnace Creek tomorrow, since this takes place at 11:15 in the morning. So I'm going to zoom in on this location here and keep going in closer and closer and closer, and you can see, hopefully you can make out this center line here. So if I pull over on the side of the road right here, or where the ISS is going to transit the sun, unfortunately, this is a two-lane road, one lane in each direction. It's narrow shoulders. I don't really like setting up that close to the side of the road. So I'm going to probably back up to Echo Canyon Road here. And you'll see the difference when I get off of the center line. So here's center line. And if I pull off on Echo Canyon Road here, now you can see that it's moved just a little bit off center. Still a fantastic pass, though. 11:14:29 is my time now. So this is our setup location. So the next step in the process, knowing exactly what time it's going to happen, is you got to be concerned about Mother Nature here. So we're going to look at the forecast. This is the forecast for Furnace Creek, which is in Death Valley, and you'll see we're looking at sunny skies tomorrow, which is great because after 1 p.m. it's looking at partly cloudy. So I'm hoping that this forecast holds true, and at 11 o'clock. This was my concern. North-northwest winds at 19 miles an hour. But one of the reasons I chose this location is because you can see by the relief map here, this is a mountain range here. There's another higher mountain range over here. So this road is sort of down in a little bit of a valley, protected from the winds. So that's what we're hoping for. And we're going to just make a go at it. The next step, of course, is gear checklist, making sure you've got everything. You only get one shot at this. I have a little tent that I actually bring. It's a dark tent. It's actually designed for hunters. I set it up, and I set a table and my laptop and everything up inside the tent because my laptop screen I cannot see in daylight. It is just, even at its maximum brightness, it's washed out. So that's one disadvantage of doing these solar transits. The evening or the lunar transits are much, much easier to capture. So from there, we'll go to getting all the equipment ready, and that's our next step. Okay, so here we are at the truck. We've got everything loaded in. We start out with our little folding table. We've got two lawn chairs here just for comfort. This is the little hunting tent that I was telling you about, so it enables us to be able to see things in the daylight here on the laptop. The black Pelican case there is the mount. It's an Ioptron ZEQ25 mount. The yellow case is my Lunt 80 millimeter hydrogen alpha telescope, and then tripod for the mount, and then film camera tripod, which I'll have my DSLR along with us. This is a little fold-up table that works great for just keeping stuff off the ground. My Goal Zero battery, which will power everything up, And finally, probably the least necessary, but it sure is nice having, is I've got a little Samsung 40-inch television monitor that I set up and use extended display that just sits on the table inside the tent. That makes it super easy to see things on the screen. That's pretty much it. That's the gear. It's everything I need in order to make a solar transit happen. One thing I should mention is when I went through the checklist here is the laptop is not yet loaded. That'll be the last thing I load, and I leave myself a note next to my key fob for my vehicle here to make sure that I don't forget my laptop, because that would really stink to drive 2 hours and get set up and then realize I left the laptop. But I leave the laptop out because right before I leave, I check to make sure that the position has not changed for the transit, so that I don't have to shift my setup location anywhere on the road. But other than that, we've got everything. I just went down my checklist. We've got the camera, the solar scope, the mount, the batteries, tripod, the tent, the table, the Goal Zero battery, my monitor, chairs, and the toolbox. So everything's loaded in the car, ready to go for tomorrow morning. Okay, so it's morning of. We're about 4 hours from the transit, and I'm getting ready to leave, hit the road, pick up my buddy, and head out towards Furnace Creek. And just like I mentioned in the video yesterday, right before I leave, I want to always check. And the position has actually changed. If I zoom in on the map now, you can see here's the Echo Canyon Road, and now the centerline path is just to the sort of southeast of the Echo Canyon Road. So Echo Canyon Road is going to be where we turn off. We may just turn off Echo Canyon Road and go down about 1/4 of a mile to this location here, and set up hopefully in a little secluded area where we don't have any problems with the wind. So that's pretty much it. We are good to go. One last quick check of the weather, and we are still looking at sunny and wind, 20-mile-an-hour winds. So not the greatest as far as the wind is concerned, but I do like the fact that it's sunny until at least 1 p.m. So our chances are pretty good today. Okay, so we're at about T-minus 6 minutes here, and so I'm going to do the first of a couple of test records just to figure out what kind of frame rate we're getting. And looks like I'm recording a capture area of 1800 by 1800 pixels, which gives me just enough coverage to include the entire disk of the sun, a little bit of leeway on both sides in case the solar guider does not keep track very well. And we're capturing at 27.5 frames, 26 frames, back and forth between 26 and 27. So figure I'll capture about 13 frames of the ISS as it transits across the sun here in the 0.6 seconds that we've got coming up. So one of the things that my buddy Glenn here just reminded me of is the importance of the accuracy of time. We're talking about an event that only lasts 0.6 seconds. So I don't want a huge video file to deal with because I believe after several minutes the frame rate probably slows down a little bit. So we want to try to keep our video clip to about 30 seconds. Luckily, he's got a Garmin GPS unit here. We know the GPS time is dead on accurate and the same time that the software uses. So we're good to go here. Give us a countdown, Glenn. It's 9:30. 9 minutes 30 seconds after the hour. and our pass happens at 14 minutes and 30 seconds after the hour, 14:30. So I'm going to probably start recording at 14 minutes according to the GPS time, and that should give us about a 40-second clip, easy to deal with. All right, we're inside of 2 minutes here. As you can see, as I zoom in, the disk of the sun here is, actually I'm zoomed in. If I set it to auto, you can see the entire frame. That's my alarm. Yeah. So we're going to watch it zoomed in a little bit because we know it's going to be close to the center line of the pass here. And we're good to go. Let's set the camera back up over here.
Got 1 minute out.
Okay, we're 1 minute out, guys. At the 30-second mark, we will start capture.
Just as the wind starts howling.
Just as the wind starts howling here. All right, we are about T-minus 30 seconds until record starts. T-minus 30 seconds. All we can do is just hope for a little gap in this wind, and we'll have a successful capture here. That wind is really kicking right now.
And a car's coming.
Is there no?
Sounds like it.
It does sound like it.
Okay, 59:14.
Okay,
Roll.
we're 30 seconds out from transit, so we are rolling, and I will be ready to stop as soon as we see the pass. That way I know that we've caught the transit right after the pass happens. Keep an eye on your time. 14:30. 14:30.
23, 24, 25, 26, 27, 28, 29.
There it went.
Ah! And I think I got it in my camcorder too.
All right, we caught it. So all of this work for 0.6 of a second of transit time here. So we have a successful capture. Looked pretty clean too. It wasn't too windy right at the time of the pass. So we're gonna stop records now and go back and review this clip and see how she turned out. So.
Ooh, good timing.
There was another little satellite that went in the opposite direction right before it, and I really kind of see it right there. It's kind of going in this direction.
Oh, wow.
And I thought that was
Nice.
it. So there we go. There's a freeze frame from the capture. Hopefully we can clean that up and sharpen it a little bit each frame and